Hi everyone, welcome back to Mechanics of Materials, Chapter 5, Torsion. In this configuration, we have a combination of shafts and gears, which is free at one end and fixed at the others. And we want to calculate the angle of twist at free end A if it happened to handle a torsional torque of 1200 pound-inches. So in such problem, we can easily see the same. There is a contact force between the two gears, as you can see here, and the same torsional torque which applies to A is applied to gear B, which is induce a opposite torsion in the gear E. And by starting this problem, we can first jot down equation of torsion. Angle of twist is equal to TL over GJ. In this equation, T is torsional torque, L is length of the shaft, J is shear modulus, and G is shear modulus, and J is polar moment of inertia. Definitely, the angle of twist is equal to phi in terms of radian. So in such problem, we start the relation from the free end moves toward to the gears, and then as soon as we get those relation between the contact force, tangential force between the gears, we can start from the fixed end of F to get the rotation and move on to get the angle of twist at A finally. So let's see how it goes. As you can see, there is a tangential force or contact force between the gear teeth of mm, gear B and E over here. We call that the contact force or tangential force. And if we want to know what is the relation between the gear teeth due to this tangential force, we can easily see first the same amount of force which applies the same amount of moment which applies to shaft AB is applied to gear B. So TAB is equal to T at gear B, and it just create another torsion in the opposite direction in the gear E. So as we do know, there is a contact force, the same contact force between the gear teeth and tangential force between the gear teeth. It just says, for example, in the bigger shaft gear, RE times force is equal to a T. Let's say RB times F is equal to torsion is kind of a moment, so that's nothing but force times R. So if force remains the same, that's TAB over RB again, and that's also equal to TDE over RE, because again force remains the same in both of them. So in such case we can get the relation of a torsional torque between the two gears due to the contact force. So again, contact force remains the same, so TA over RE is equal to TB over RB. We have the relation between the radius, so we can easily get the torsion of E is equal to 6 over 4.5 times 1200. And if we now we can start from the fixed end at F, phi E over F, or phi E with respect to F is phi E minus phi F, and phi F is 0 due to fixed end. So phi E is equal to TL over GJ. Let's move to the twist in shaft FE over here. So we have the length of 12 inches of this shaft. C is a half of diameter, which is 7 over 16, and G is provided to be 11.2 megapascal. And J is a half of pi r to the fourth, and that's if you calculate the numeric value, it's this amount. So if we jot down the numeric value in the equation of phi ETL over GJ, it just gives you this numeric value in terms of radian, and we do know phi EF is equal to phi E. So far we have started from F, we get the tangent angle of twist up to here, and we move our problem to B, then move all the way to get the angle of twist at A. So let's jump to our gears again, gear at E and B, and using the kinematic for equal peripheral gear motion. So again, if you look at the configuration, you can see due to the same contact force, the displacement is equal in terms of their arc. So these two are equal to each other. These motion are equal, and one of them is RB times phi B, and the other is RE times phi E. If they are equal due to kinematic for equal peripheral gear motions, we can easily get the relation. We already calculated phi E in last part, and now we can get the relation of angle of twist in gear B based off phi E, and that's equal to this numeric value in terms of radian. So then as soon as we already started from here, we get the angle of twist at E, then we get angle of twist at B, at gear B, which is this amount of value. And now let's jump to the twist in shaft AB. This is shaft AB. So the length of shaft AB is equal to 8 inches plus 6 inches, which is made it like 14 inches, make it like 14 inches. J is this amount if you calculate it. And then phi A over B is just TL over GJ. And if you replace the numeric value in the main equation, it just gives you this numeric value 26.065 times 10 negative a cube in terms of radian. And then phi A is nothing but phi AB plus phi B plus phi A with respect to B. And if you jot down the equation, it just gives you phi A is equal to phi B, which is we already calculated, it's here, then plus phi AB, which is here. If you add them up together, it just gives you this number, which is 65.783 times 10 to negative 3 radian. And that was where we were looking for. And if you convert it to degrees, it just says in this configuration with a 1200 pound-inch torque applies at A, it just gives you angle of rotation or angle of twist of a 3.77 degrees. Thank you. We'll solve more interesting problem in torsion.